This is Mr. Tomlinson, and this is practice exam number 2, solutions. Okay, so I'm given the quadratic equation right here at x equals negative, or y equals -2 times x minus 7 times x plus 5. So it asks, what is the equation of the axis of symmetry? I know it's going to be the average of the x-intercepts. Well, whatever makes these two 0 are the x-intercepts, so that'll be x equals 7 and x equals -5. So if I take 7 plus -5, and I average those, that will be the axis of symmetry. So that'll be 2 over 2, or x equals 1. Okay, so given that this is the axis of symmetry, to find the coordinates of the vertex, I simply plug the x coordinate of the axis of symmetry into my original equation up here and get the y. So I went ahead and did that, and I got 172. Simply plug 1 in here into the original equation, and plug 1 in for x up here, and I got these values, and then I just simplified and got 72. Okay, so I'm required to write the x-intercepts, the y-intercept, and the vertex on this graph. So what I did here is I labeled it, vertex is here, x-intercept's here. Then to find the y-intercept, I simply plugged x equals 0 into the original equation, and I got y is equal to 70, because -2 times -35 is positive 70. So that means my intercept is here, and I also know that an equal distance away, notice the scales are a little different, so this is 1 unit away, 1 unit away, I went over the 1. Now I've got 5 points on this graph, and I'm just going to draw a smooth curve, or not so smooth. I'll do my best here. It should be going there. Sorry, that's a little bit rough, but you get the idea that this is a parabola with this as a vertex, axis of symmetry right here. X equals 1, and we're finished. Okay, for number 2, we're looking at a table for selected values of a quadratic, and then I'm looking for symmetry. So I see where are the y values the same, and I see the y values here and here are the same. The y values here and here are the same. And since these are equidistant from this means this is the vertex. Okay, so immediately I know that I can write an equation, y equals a times, okay, x minus 3 squared minus 12, because 3 negative 12 is the vertex. All right, so now I need to solve for a. I pick one of the points. I'm going to pick 1, -8 to solve. Okay, so I put in -8 equals a times 1 minus 3 squared minus 12. So I'm solving for a. So this is 1 minus 3, which is -2, which is squared is 4. So this will be 4a minus 12 equals -8. I add 12, divide by 4, I get a equals 1. So my equation is y equals x minus 3 squared minus 12. Finished. Now, if I want to write this in standard form, simply square this and subtract 12. So I went ahead and did that. I got x squared minus 6x plus 9 minus 12. I subtract that, and I'm finished. Okay, for number 3, I'm just filling in the blanks, so I'm going to FOIL or factor as needed. You go ahead and do that. Next ones are just simply foiling or solving, I should say. So here, if it's already factored, I just set the factors equal to 0, x minus 11 equals 0, or x plus 7 equals 0, and that means x equals 11, or x equals -7. In the next problem, I don't see this as factorable, so I see that I'm going to use the quadratic formula. So for b, I just did b squared minus 4ac here, which is 25, minus 4 times 1 times -2, which is 25, minus a -8, which is 25 plus 8. That is equal to 33, which I'm then plugging into the quadratic formula, and I'm getting this. So you have two answers, -5 plus or minus the square root of 33 all over 2. Okay, so for this last one, all I did was plug in b squared minus 4ac using the quadratic formula right over here. I get 1 minus 4 is equal to -3, which means my answer is x equals -1 plus or minus the square root of -3 all over 2, which is, I have to take that 1 out and make it I, so this is 1 plus or minus I root 3 all over 2. It's two possible answers, both imaginary. Okay, so in this one, for the next few problems, for the rest of this, I'm just gonna walk over written out answers. But first thing I'm gonna do is I need the equation in vertex form. So I found the vertex, and I did negative b over 2a, and I got negative 3/2, and then I plugged it in to get the y coordinate, which was negative 6.25. So x plus, because this is minus, x plus 3/2 parentheses squared minus the y coordinate of the vertex. This is minus, it's the same, it's consistent, since our vertex is this. Then, what are the solutions to this? Well, this is factorable as x plus 4, x minus 1. So I just simply set these two factors equal to 0. X plus 4 equals 0, so x equals negative 4, or x minus 1 equals 0, x equals 1. Okay, so remember, just as a reminder, we're going to take whatever I is raised to the power, we're going to divide it by 4, and whatever our remainder is what it is. So I had or 171 divided by 4, left 42 with a remainder of 3 here. And so since that is a remainder of 3, that means this same thing is the same thing as negative I, which is equal to I to the 171. From there on out, we're just treating I like an X. We're just combining here. 3 minus 12, we combine the like terms, that's negative 9. 8I plus 3I is 11I. Remember, 8I, that's minus a negative 3I, so that becomes plus, okay, over here. All right, now, this is 5 plus I, 5 minus I. I know this is the difference of squares, but just to show you, if I FOIL it, it's plus 5I minus 5I, or minus 5I plus 5I, so those will go away. And then 25 minus I squared is the same thing as 25 minus a negative 1, which is 25 plus 1, which is 26. Okay, I to the 64 times I. This is I. I could do I to the 65th and plug it all out, but I to the 64 is just 1. So if I to the 64 is 1, this is the same thing as 1 times I, because I know 64 is a multiple of 4. So 1 times I is just I. That's final answer. Okay, for this problem, I look at the graph and I see it and I say, well, this thing doesn't cross the x-axis, so there are two imaginary solutions because there are no x-intercepts on this graph. Write an equation for the function. Well, I took the vertex, 0 and negative 1, and I wrote y equals x minus 0 squared minus 1. You can't leave it like this. You got to finish this. Actually, make sure this is negative because a is negative, so this is negative x squared minus 1. How did I know a was negative 1? I went up here to the vertex, I went over 1, and then it goes down 1. So it went to the left 1, down 1, to the right 1, down 1, so that makes a negative 1. This a has to be negative because it opens down. If you have an a that's positive, then you miss the point of the whole thing. If a is greater than 0, it opens up. If a is less than 0, it opens down. Okay, what are the real or imaginary solutions? So I take negative x squared minus 1 equal to 0. I add 1 and then multiply by negative 1 to get x squared equals negative 1. I square root both sides, and it's plus or minus the square root of negative 1, which x equals plus or minus I. Next, we have a quadratic equation that's given here, and it asks you what is the value of the discriminant. The discriminant, b squared minus 4ac. I plug it in, I get 4 minus 32, or negative 28. How many solutions, real or otherwise, does the equation have? It has 2 solutions. And what type of the solutions are they? They are 2 imaginary solutions. Okay, so the graph shows the relationship between the number of minutes in Amanda's workout and her heart rate in beats per minute. So what's happening is her heart rate, as the workout starts to go up. And what's happening is this heart rate is going up and up and up. And then it reaches a peak right here after 15 minutes in the workout. So if we interpret this to mean after 15 minutes, her heart rate is 140. Is 140 beats per minute, BPM. Now, I want to find the solutions where the heart rate is 105. So that would be like right here and about right here is my guess. Somewhere, my guess is it's going to be 5 and 25 minutes, but I don't know exactly where it is, but it's right here where the beat is about 105. So I'm going to calculate this. I take the 140 and I subtract it. I get minus 35 equals negative 0.35 times x minus 15 squared. And then divide by negative 0.35, I get 100 equals x minus 15 squared. And then I'm going to get x minus 15 is equal to plus or minus 10. So basically, it's if I add 15 to both sides, I get 15 plus 10, which is equal to 25, or I get 15 minus 10, which is equal to 5. So it's either 5 minutes, which is right here, 5 minutes, or 25 minutes, where we reach 105. So my estimate was pretty spot on accurate, but it's either 25 minutes or 5 minutes, where the heart rate is 105 BPM. BPM. Okay, so we're going to start with the axis of symmetry. It's x equals 2 because the x-coordinate of the vertex is 2. I know that A opens up, so if I'm going to write the equation if I'm going to ask the question, is A positive or negative, this thing opens up because A is greater than 0. So this is definitely A is positive. To find the value of C in an equation like this, y equals ax squared plus bx plus c, I want the value of C. All I have to do is look at the y-intercept, 0, negative 4. That negative 4, it's always going to be 0 wherever the y-intercept is for x. The y value is negative 4. That is the value of C, because if I put in 0, 0 here, this makes this whole thing go away. What's left is C. So C is the y-intercept, which is negative 4. What is the domain and range of the function? Our domain for these parabolas will always be all reals. The range, since it opens up, is going to be y is greater than or equal to the y value, which is negative 8. So I can write this in interval form, negative 8 inclusive to infinity. You can't write y is greater than 8. That's not a complete solution. That's a meeting solution, not an exemplary solution. You have to write greater than or equal to, this, or you have to have it included. So now you're asked to graph the equation, x squared minus 4x minus 6. So the first thing I did was I found the vertex. The vertex is x equals negative 4 over 2 times 1, and that is 2. I plugged 2 in to get the y-coordinate here. And if I get the y-coordinate, I get negative 10. I plug it in. I get 2, negative 10 is the vertex, so I plotted the vertex. Now I know that A is 1, ax squared, so I went 1 to the right, 1 up, 1 to the left, 1 up, okay? So I've got 2 points here. I have enough to draw a smooth curve, but I'm not done yet. So what I'm gonna do, actually, I have to pick out the x-intercepts. The way I do that is I solve for the x-intercepts by finding b squared minus 4ac and using the quadratic formula. X is equal to 4 plus or minus square root of 40 over 2. Again, b squared minus 4 times a times c, and that's 16 plus 24, which is 40. Okay, now I also simplified that to be 2 root 10 because I simplified the radical. This is 4 times 10, which is the square root of 4 times the square root of 10, which is 2 root 10. Now I could cancel the 2 out with each of these, so this becomes 2 plus or minus root 10. But root 10 is about 3.16 on the calculator, so 2 plus 3.16 is just a little more than 5, and 2 minus root 10 is just a little less than negative 1. Okay, so there are your two roots, 2 plus root 10, comma 0, and 2 minus root 10, comma 0. These are exact values. If you wrote them as negative 1 point whatever and 5.16 or whatever, comma 0, that would also be okay. Our axis of symmetry is here, x equals negative 2. Okay, so our last problem is writing down the axis of symmetry of this graph and then plotting 2 additional points that are on the graph. Once I write the axis of symmetry, I know that this point is 1 unit on the x away from here. Because of symmetry, 1 unit away is 6, 3. Because this is 4, 3, which is 1 unit away from the axis of symmetry, which is x equals 5. Down here, I use the same method. This is 3 units away. This is also 3 units away to the positive. So 5 plus 3 minus 3 will also be at -5 on the y. So the point here is 2, -5 right here. That's it.